So, let's get into a little bit more of the nitty-gritty. A couple of interesting rules that I put in for these things is that with berries are not able to reproduce if the berry that it's reproducing wants to be on the same square as the reproducer. This makes it so that there is a statistical likelihood of that a plant will just not be able to reproduce because of circumstances that are outside of the control of the plant. The same goes for mites. And that also, when one of these wants to reproduce, it has to check to make sure that the box that it is attempting to go to, say this one, the reproducing berry wants to go to this box. If this box is occupied by a mite, it can't do that. So it will just not do it. But mites are somewhat spared from this process due to the fact that when this happens, their health doesn't necessarily get as penalized from it. The berries, on the other hand, don't have such a luxury. So one of the interesting things that we saw in early iterations of the game, which still can be showed, is that after a million iterations or so, or however many you want to do, the berries will still be remaining, and they will not take up every square. So when we go and we see this first run, you will see that the berries are numbers and that the mites are letters. If we run, say, 15,000 iterations, which is highly unlikely for mites to be able to survive.
3 hours later.
Okay. So, this is from the last iteration, and essentially what we see is that all that remains is berries, but they have not covered the entire screen. And in the areas where they are occupying, there are these pockets, because essentially every time that a berry plant occupies an area, it wants to be able to reproduce. But if there are other berry plants around, it becomes exponentially harder for it to reproduce, which makes the likelihood of that square to become occupied to be less and less and less and less until it's almost 0%. But it will never reach 0. It will always have a chance to be able to occupy that square whilst the other squares are occupied. This means that the mites are meant for the berries as much as the berries are meant for the mites, which is extremely intriguing. So when asking the question of reproduction of, say, a mite, we're going to be using some numbers, okay? First thing that I kind of wanted to play around with was the idea of health. If you have a mite and it has a health of 100, meaning that it's 100% healthy, okay? Or say, how about 85? A moderately healthy mite, and it wants to reproduce. It took 2 berries, wants to reproduce. What does it do? Well, it reproduces, but it's not guaranteed that this mite that it reproduces to get will have the same health. Because if it had the same health, that doesn't really make any sense. Because it hasn't really done anything to deserve it, you know? So, let's say that it has a plus or minus of 85 of the 85 health that the birthing mite has. Okay, so it could either be 95 or it could be 75. Okay, so if it gets 75, okay, that means it got a pretty bad hand in life, you know? It got sort of dealt a bad hand of not having a good immune system, and it wasn't able to do well during that sort of process in life and whatnot, and it didn't go so well. But let's say that the other side is true. Let's say that's 95. Well, that's pretty good. It means that it was strong, it did really well. See, what you might think is that, oh well, this is a random event. This is something that is pretty normal, but it doesn't seem to really sort of connect to what we're talking about evolution. Well, let's look at it this way. So let's back up, okay, to where we have these two mites, okay? And let's say that mite A, that's what we'll call this one. We'll give it a little A down here so that you can see that. This one will be mite B, okay? So if mite A has 100% health, say first round, this is what it does, okay? Eats 2 berries, it gets the ability to reproduce, successfully reproduces onto the next square. Then what happens here? Well, if you were to keep the same value, of what we did for everything else, the same code and everything, there's a possibility that, statistically speaking, it could have 110 health. Now you might be thinking, whoa, 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 that's really unfair, you know? The other mites don't have that chance. They might not have that chance. But the thing is that that's the purpose, is that because of randomness, specific mites should be able to do better than other mites. So let's say that we keep going along with the story, and let's say that this mite goes away. He doesn't necessarily make it. This one's surviving on, okay? And this next iteration, it eats 2 berries, it's able to reproduce. Well, now if we look at it and it reproduces into this square, it has the possibility to be able to get 120 health, okay? Which means that if this keeps going and every single iteration the next birth mite eats 2 berries right away, it should be able to create super mites that are able to survive for longer. And essentially, there's no cap to this, which means that it can go as long as you want. It can do as much as you want. Theoretically speaking, from this code being added, you could have mites that are able to survive a drought by being able to store more, by having a higher capacity, because they've sort of developed that, by making it so that, let's pull up a wave here. I love Desmos, so let's pull up Desmos, okay? Let's pull up a wave. So let's say that the berries reproduce, and they reproduce, and they reproduce, and they occupy a whole bunch of space, okay? So the super mites are able to really flourish off of this, but they take a lot of the berries. That's one of the big things about the super mites, is that they take a lot of the berries because they need them right away. If they don't, the likelihood of them being able to increase again decreases. But then let's say that the berries go away because of this. They go away, they go away, they go away. There's an equilibrium, then they keep going down and down and down and down and down and down. So at this point, the mites that don't have this super ability would die off. Now, typically, in the code that I wrote, we were seeing that around iteration 10 or 11, which is that since they take 10 damage each time, without having another berry, they die around iteration 10 or 11. Now, there are exceptions for some that scrounge up berries and whatnot, where they live on to 16 or whatnot. But if you have a super mite that is able to have the ability to have 200 health or so as their starting value, they would be able to survive from here down through the drought and then up to the next surplus. And by surviving to the next surplus, they have guaranteed their chances of being able to reproduce. Now, it's not 100% guaranteed. It's not like, okay, great, I made it, I'm here, okay? This mite could be in an absolutely droughted area in the map and still die in this next droughted era. It all depends on likelihood and on randomness. It's all just like dice. And you can't predict a die, and you can't predict this. But what we are working with is the fuzziness of what we can predict will most likely happen. So this is interesting, and that is why in the code I put this comment on line 123, which says accidental mutations supermites, which sort of shows that this is where we had the first contact with mutations, which is really interesting. So,